video, we are going to cover operations with radicals. After studying this section, you'll be able to simplify radical expressions and solve expressions that have radicals. So simplifying radical expressions. When I simplify a radical expression, I want to look for the biggest perfect square that I can take out of my radical. So when I'm looking at my first example, I have the square root of 20. Now I know 20 is 5 times 4. 4 is the biggest perfect square that goes into 20. So if I simplify the square root of 20, it's the square root of 5 times the square root of 4. The square root of 4 is 2, so the square root of 20 will be 2 root 5 simplified. Number 2, I have the square root of 56. Now, if you're not good with identifying what the biggest perfect square is, I can always make a factor tree. So 56, if I list two factors of 56, I know that 2 and 28 multiply to 56. Now 28 can be broken down into 14 and 2, and 14 can be broken down into 7 and 2. So my factors, or my prime factorization of the square root of 56, is 2 times 2 times 2 times 7. Now, if I am using the square root, I want two factors of the same thing to be able to take it out of my radical. Notice I have two 2's, so I can take out one 2. Then I have a 2 and a 7 left. Those don't share the common factor, so that would just be the square root of 14. So the square root of 56 would be 2 root 14. So the biggest perfect square that I could have taken out of 56 was 4. Number 3, I have 5 square root 72. So the root 72 I need to simplify. I know the biggest perfect square out of root 72 would be 36. So 36 and 2. The square root of 36 is 6. When I take something out of my radical, I multiply it by the coefficient in front. So 5 times 6 will be 30, and then I'm left with my root 2. So 5 root 72 is 30 root 2 simplified. Now, if I want to multiply my radicals, I simply multiply their coefficients and multiply what's inside my radical. So the square root of 3 times the square root of 2 is the square root of 6. I need to make sure that I simplify the radical if I can. Square root of 6 I cannot simplify, so root 3 times root 2 would just be root 6. Number 5, 3 root 5 times 2 root 3. I'll multiply my 3 and my 2 together. That will give me 6. I'll multiply my root 5 and root 3, which would be root 15. I know root 15 cannot be simplified, so I have 6 root 15. So negative 3 root 7 times root 7 is negative 21. Again, multiplying some of these out, root 5 times 4 root 5 would be 4 times 5, which is 20. Root 6 squared would be root 6 times root 6, which is 6. And negative 3 root 5 squared would be negative 3 root 5 times negative 3 root 5. So negative 3 times negative 3 is 9, and root 5 times root 5 is 5. 9 times 5 is 45. Now I want to simplify using division, and I want to make sure I rationalize all my denominators. So when I have two radicals being divided, I can bring them underneath one radical. So root 20 divided by root 5 is also root 20 divided by 5. I know 20 divided by 5 is 4, so root 4 is 2. 11, I have 12 root 18 divided by 36 root 6. The way I want to handle this one is I want to simplify my coefficients first, as well as my radical. So 12 divided by 36 is 1/3. That would be essentially multiplied by root 18 divided by 6. 18 divided by 6 is root 3. Root 3 would be in my numerator, and 3 is in my denominator. So I have root 3 divided by 3. My last one, 12, I have 1 divided by root 2. So here is where I want to rationalize my denominator. It's not correct to have a radical in my denominator. So what I will do is multiply by the radical that is in the denominator. So I will multiply 1 over root 2 by root 2 over root 2, which is just a factor of 1, so I'm not changing my problem in any way. 1 times root 2 is root 2. Root 2 times root 2 is 2. So my simplified radical is root 2 divided by 2. Looking at some addition and subtraction examples, I will treat these essentially as I'm treating adding and subtracting coefficients with variables. I add the coefficients, I don't add my variables, and I need to make sure that my variables are the same. So when I look at 13, I have 2 root 3 plus 7 root 3. 2 plus 7 is 9, and I'll keep my root 3 the same. So I have 9 root 3. 14, I have 7 minus 5 root 7. So this would be negative 4 root 7. And 15, I have negative 2 root 6 plus 3 root 24. Notice that root 6 and root 24 are not the same. I need to make them the same if possible. So I want to make root 24 simplified to be a root of 6. I know that 24 is 4 times 6. The square root of 4 is 2. So I would have negative 2 root 6 plus 3 times root 4 times 6. Again, the square root of 4 is 2. When I take that out of my radical, I would multiply it by the 3. So this would be negative 2 root 6 plus 3 times 2 is 6 root 6. Now I have the radical the same, so I can add. Negative 2 plus 6 would be 4, so this would be 4 root 6. Some more subtraction and addition. 5 root 18 minus 7 root 72. Again, these are not radicals that are the same, so I need to change them. I know root 18 can be simplified. That would be 9 times 2. Square root of 9 is 3, so this will be 15 root 2. So 72 I will want to change to radical 2. So 72 we did earlier, that was 36 and 2. Square root of 36 is 6. 7 times 6 is 42, so minus 42 root 2. 15 minus 42 would be negative 27 root 2. 17, I have 2 root 12 minus 5 root 48 plus root 3. So 4 minus 20 plus 1 would be negative 15 root 3. And my last one, I have a distributive property, so root 6 to root 3 plus root 10. So I'm going to distribute my root 6 into both my 2 root 3 and my positive root 10. So 2 root 3 times root 6 would be 2 root 18 plus root 60. Root 18 we just did. That is 9 times 2, which is 3 root 2. So 2 times 3 root 2 would be 6 root 2 plus root 60. Root 60 is 4 and 15. Square root of 4 is 2, so 2 root 15. Notice that my radicals are not the same and they cannot become the same. So this simplified expression would just be 6 root 2 plus 2 root 15. In my last section, solving equations that involve radicals. So 19, I have root x plus 20 is equal to 0. I'm going to add 20 to both sides to get me root x is equal to 20. In order to get rid of the square root, I will square everything. Root x squared would just give me a single x. 20 squared is 400. Root 2x minus 1 is equal to 7. Again, I'm going to add 1 to both sides to give me 2x is equal to 8. I will square all my sides, so 2x equals 64. I will divide everything by 2, so x is equal to 32. And then 5 root 3x plus 4 plus 1 is equal to 21. Notice my plus 1 is not inside my radical, so I will subtract plus 1 from both sides to give me 5 root 3x plus 4 is equal to 20. We'll divide all my sides by 5 to give me root 3x plus 4 is equal to 4. Now I will square all my sides. If I square the square root of 3x plus 4, that will be 3x plus 4. And the square of 4 is 16. I will subtract 4 from both sides. So 3x equals 12. I will divide by 3 to give me x is equal to 4. In today's lesson, we learned to simplify a radical, find the largest perfect square to pull out of the radical. To perform addition and subtraction, make sure your radicals are the same. And to perform multiplication and division, multiply or divide the coefficients, then multiply or divide the numbers inside the root. That's a wrap on today's video. We'll see you in the next one.